Hi guys, I'm Mihai John and I would like to invite you again in Wonderland. Today I want to show you how to build an air handling unit. So this is an air handling unit, but what is an air handling unit without parts inside? It's just a box. And what we intend to do with this air handling unit, we want to control the airflow and the air quality. Coming back to my story, what can I say? An air handling unit without parts inside like motors and heat exchangers is nothing but a box. And you can't use a box. To direct the airflow, we use dampers. Dampers could be manual controlled, like you see in this video, and obviously you will not do this with the damper, otherwise you'll ruin it. I just want to show you how it's working. Or they can be automatic, driven by an actuator. Going further, we'll observe here that a damper is not necessarily 0 and 100%. They can be proportional. Like in this case, you see this fan will suck air either from the horizontal damper or from the vertical one. It's up to how you choose to control the airflow. In this particular case, the damper must be 100% open before the fan will be activated. Otherwise, the supply air chamber will act like a blocked vacuum cleaner. What you will see here, it's an integrated damper. So when the damper will open, we'll instruct the PLC to turn on the variable speed driver that controls the motor. And now, we understood that by using dampers, we want to direct the airflow whenever we want the airflow to go. So let's see a little bit deeper how this is working. Imagine this is an AHU. You do not have heat exchangers, nothing, just dampers. As you will observe, you can bring more fresh air into the system, you can exhaust more air, or you can recirculate air. This is your decision. You will write the control philosophy and you will decide what to do with the air. But to circulate the air through the system, you need motors. And this, it is a plug motor. It is a scroll one. This motor circulates the air through the system. But there are many other types of motor you can use. It's not only this. Look at this. Axial motor. These motors will circulate also the air, but into the supply chamber you'll have a positive pressure. And that will give you a complete electrical and mechanical redundancy. I will talk about this a little bit later on. Another type of fan you can use, it is a scroll but belt-driven one. Again, on this situation you'll have a negative pressure onto the supply air chamber. I'll talk about this later on, but I think I had another YouTube video that talked about this more in detail. Coming back to our story, this is our box. It's an AHU. To circulate the air we need motors. To direct the air we need dampers. And once you'll have motors and dampers, you'll be able to control the airflow, the air quantity, and the air direction. And what you'll see here, it is how the air circulates through the air handling unit and how the air reaches the rooms. Also, you'll see how the air will return to the extractor fan. Part of the air will be exhausted and part of the air will be recirculated. And here you will observe that there's a programmable logic control that controls the fan through the variable speed driver. Now, coming back to our AHU. AHU need dampers, and to circulate the air we need fans. But then we have to control the air temperature. The fresh air intake is controlled by a frost heat exchanger. They have to be filtered by a primary filter, and then we have to remove the humidity by using a primary cooling coil. Then we have the main filter, because the return air must be filtered as well. And main cooling coil, because we want to trim the air temperature. And the heating coil, to heat or to reheat the air as needed. And a humidifier, in case we remove too much moisture while we're cooling the system. All these things need to be controlled by something. That's why we use actuators, velocity probes, differential pressure switches. And what controls this? A programmable logic control, and you can see it on a HMI. All these heat exchangers are controlled by actuators. Like you see here, the actuator have the capability to divert the flow. This is a hot agent which will pass by through a valve, and the valve will direct the flow to a heat exchanger, or it will recirculate the flow if the temperature it is satisfied. Going further with this, you'll observe that the valves are not always 0 or 100%. They can be proportional, a PID. So this valve will allow more or less cooling or heating agent to pass by accordingly to the heat demand. That will give you a better control. So the cooling and the humidification, heating and humidification coil will be controlled by these actuators. You will see this one a little bit will make more sense to you. A building management control will control the actuators that allows the heating or cooling agent to pass by and to cool or heat a heat exchanger that will further cool or heat the air. This actuator is a three-way valve, control a three-way valve, and as you will see here, it's not 0 or nothing. It is PID, which allow more or less heating or cooling agent to pass by. When you design an air handling unit, you have to look at this. Everywhere you see a question mark, it's a place where you have to pay attention, not only on the control, but on the design. Now you end up with a fully functional air handling unit. It's using this axial fan, and like I told you before, this axial fan is great. It gives you a complete electrical and mechanical redundancy. You can use a scroll fan, which will give you a complete redundancy if you know how to design it. Bear in mind, each of these fans must have the capability to provide the amount of air on its own. You can use belt-driven fans. Now, I want to talk more about the belt-driven fans. Just like the axial one, these belt-driven fans are using belts, and the motors are outside the supply air and the extract air chamber. They pro and cons, and I will explain to you how this belt-driven fans working. This is the image you will see when you look to the air handling unit from the front. You'll observe the scroll that moves, the pulleys, which are in a cage so people will not get hurt, and the motor, which is outside. This is a great system because this motor is outside, doesn't generate heat inside the supply air chamber, so I don't have to stress the heat exchanger. If you take out the cover of the AHU, you'll observe the plumber blocks, the pulleys. You'll observe better how the system works. You'll even see the shaft. But that's not enough. Let's go 3D. To have redundancy, we use two motors. One of the motors gets broken, the other one should take over, like in this case. If this motor have an electrical fault, the programmable logic control will swap the motors and the other motor will continue. But the first motor will be pulled by the second motor. If you have a mechanical failure like a bearings, you see these motors are connected to the belts, and regardless of which motor get broken, the other motor will be affected and the system will stop because we don't have a mechanical redundancy. And if you look to the red arrow, you will see the parts that are affected. Can you imagine if you have a mechanical failure to the first plumber block? The bearings are gone. Through the shaft, through the pulley, through the belts, they both motor affected, and the fan will stop. You won't have a mechanical redundancy. So this is the bigger inconvenience when you use this type of system. If you use the second plumber block, which is, we'll see now with a red color, that's the worst fault you can have, because you will apply a lot of stress onto the shaft. The motor will try to pull to turn the fan, but that won't be possible because the bearings are gone. Now people say, okay, in this case I'm going to use this axial fan. This is a brilliant fan. It gives me a full electrical and mechanical redundancy, and this is true. They're reliable. When you choose this fan, you have to make sure that each fan have the capability to run the system on its own, to provide the necessary quantity of airflow. Now, what's the beauty of this? One fan will get faulty, the other two will take over, will have the capability to supply the required amount of air, so the production will be undisturbed, and then you can remove the fan to repair it. The production wouldn't even know they have a problem. This is the beauty. Like I said, pro and cons. This fan, it's inside the chamber and generate heat, which will create a little bit strain on the cooling coil. Like the other fan, you can use this type of scroll fan, which has got the motor inside. They also generate heat, but again, you have full electrical and mechanical redundancy. You don't have belts, they're individual. You run them in pairs, and if one of them will get broken, in this case, there's not too much you can do, and I will show you what should you do to design a good system. Just like the other motors, I said they pro and cons. These motors are running, but they generate heat inside the supply air chamber. And you have to compensate that heat by running the heat exchanger a little bit cooler. But the beauty about this type of motor, you can segregate the rooms. Each fan will run in its own room. And if one of these fans gets faulty, you will observe the dampers will close and will isolate the area, so you can safely remove the fan to repair, where the other fan will compensate. Guys, thank you very much for watching this video. That was a very simple explanation about how to design your AHU, how to choose the fan, and what kind of problem you can expect with all this type of fans. Thank you very much.